Welcome to Rawson Connection, a podcast about all things Lehigh engineering. Coming to you from the P.C. Rawson College of Engineering and Applied Science at Lehigh University. It's a show for students, alumni, faculty, and staff, current, former, and future, and for anyone who's interested in the many creative ways that engineers are solving the world's problems. Today's episode is about Lehigh's efforts to help those on the front lines of the coronavirus pandemic. It's about a small team who responded immediately to calls from local hospitals who were desperate for face shields. They needed the shields as an added layer of protection for their healthcare workers, to further protect their eyes, nose, and mouth from airborne droplets of the virus. Face shields are typically worn together with N95 respirator masks, gloves, and gowns. They're a vital piece of personal protective equipment, which means they've become a very scarce piece of equipment. It's 10 a.m. on a Tuesday morning, and Trevor Verdonik is walking into Wilbur Powerhouse. Trevor is the additive manufacturing coordinator and a PhD student in materials science. And now he's also an essential worker. That's because he operates the 3D printers that make components for face shields that he helps deliver every week to local healthcare providers. Trevor walks into the additive manufacturing lab. 2 rows of 3D printers line 2 walls. The printers are rectangular and about the size of a microwave. Their interiors glow a fluorescent white. And they're quiet. They've all finished their nearly 24-hour print cycle.
So taking a look, what I can see is all the different printers that have finished printing and all the finished parts that are sitting on the printers. So each of them has a stack of 8 parts that are all just on top of each other. They'll have to be pulled off of the printer and then broken apart so that they can be assembled and distributed.
Printing, cutting, assembling, distributing. It's a process repeated by a small team at Lehigh 5 days a week, a process that began soon after COVID-19 closed campus and revealed a huge need in the medical community. It was the crisis in New York City hospitals that first got Brian Slocum thinking about how Lehigh could help.
I was seeing things in my news feed about these doctors who are literally putting their lives on the line to go in and save patients, and they don't have the proper protective gear to protect themselves. And that seemed really sad and concerning to me.
Brian is the managing director of the Wilbur Powerhouse and the design labs at Lehigh.
So primarily my responsibility is helping students across campus make things.
He began researching how people were using 3D printing to address the shortage of personal protective equipment, or PPE. At nearly the same time, he started getting emails from local hospital administrators. They were worried about their own supplies of protective gear, and they wanted to know if Lehigh could help. Brian found an article online published by Prusa Research. Prusa is a 3D printing company based in Prague, and they had developed a face shield that could be 3D printed.
Essentially, it's a clear plastic shield that covers the face, and it prevented droplets of the people coughing or sneezing from hitting the doctor's face. It increased the life of the N95 masks that they were wearing, and they had worked very closely with the Czech Health Ministry to validate their design. It had been through several iterations by this point, and they were open sourcing their design. The only thing they said was, please, we don't want to see these on Amazon selling for $50 a piece.
Brian thought it was the perfect starting point. He got back to the hospitals. Lehigh could totally produce something like this. Were they interested?
Absolutely. Hands down, the answer was yes. How many can you make and how quickly can we get them?
Brian, Trevor, and assistant manager of the design labs, Michael Moore, began iterating on the Prusa design. They were joined by another Lehigh alum and his team of engineers at Knoll, the design firm in East Greenville. Medical professionals knew of the Prusa design, and they had a couple problems with it. For one, there was a gap between the forehead and the plastic face shield that could potentially allow droplets in from above, and the elastic band that went around the head couldn't be cleaned properly. The teams from Lehigh and Knoll solved both problems. More on that in a minute. Meanwhile, the university designated the Lehigh team as essential workers. And less than 2 weeks after that first email, they had prototypes ready for hospitals to test. Now, Lehigh is making 400 to 500 face shields a week and delivering them to hospitals and emergency management agencies. Back in Wilbur Powerhouse, Trevor Verdonick is removing plastic headbands from the 3D printers.
The way that they come off the printer is pretty simple. It's just a glass tray, and the plastic just kind of sticks to it. So usually just a good pull at the base, and the part pops right off.
The headband design addresses one of the hospital's concerns. The airborne droplets could enter through the gap between the forehead and the face shield. The headband is actually comprised of 2 bands. One sits against your forehead, and one sweeps out and holds the face shield. Little pegs on both allow the team to attach a neoprene comfort guard. The guard both cushions the forehead band and forms a roof over that gap between the 2 bands. He then removes a row of slightly curved plastic pieces. They get attached to the bottom of the face shield, and they help give it structure.
The second parts that we have printed on these trays are these little bottom support pieces. They're much smaller than the headbands itself, so ideally we're printing a set of 8 headbands. So we also print a set of 8 of these little support pieces, and for the most part they just kind of pop right off the tray.
The machines also print plastic supports that hold the stack of headbands together.
Now the support material itself is the same material as the model material, so it has to be broken off. So what I kind of do is just use a screwdriver to get in between the support and the parts that I want. There we go.
Then he breaks the headbands apart.
So now at this point, I have a fully completed and ready to go headband.
The rest of the face shield is made on Lehigh's Mountaintop campus. Michael Moore, who is also an alum of Lehigh's Ideas program, operates the laser cutters that cut the plastic shield, the neoprene comfort guard, and the adjustable neoprene strap that wraps around the back of the head. That strap solved another of the hospital's issues. Neoprene can be easily sanitized. Like Trevor, Michael has his routine down.
One of the first things I have to do is come over and turn on the compressed air for the system. That blows air over the lenses on the laser cutter to help keep them clean. I have to open the actual laser cutter itself up and turn it on, which is this switch all the way down at the bottom back here.
The laser cutters look like big office printers. One is blue and one is gray. The blue one cuts shields from PET plastic, and the gray one cuts the neoprene.
And as they boot up, you can hear the fans kick on.
Michael hits a button that starts the fume extraction. Then he starts loading the machines.
My cutting table is over here with my massive bolt of neoprene fabric. So I have an X-Acto knife, and I have this lovely piece of old whiteboard that is exactly the right size and shape for the laser cutter bed. And I use that as a pattern to cut out fresh pieces of fabric to place in the machine. You can hear the increased airflow noises. That's the fume extraction kicking on.
He places the PET plastic in the blue machine. It takes about 1 minute to cut 2 plastic shields, and 10 minutes to cut 10 neoprene comfort guards and 8 straps.
And you can see the head kind of tracing over, and actually those little sparks of light from where it's cutting out the shape, so you can kind of see the pattern that gets left behind when the light is right anyway.
The machines signal when the cut is complete, so Michael's progress is marked in 1 minute intervals by a distinct sound. And because he hears that sound all day long, he likes to change it up.
There we go. And today it's the ta-da noise, which is nice.
The Lehigh team isn't just making face shields. They're also 3D printing stethoscope parts for St. Luke's University Health Network in Bethlehem. And recently, Brian had to figure out something else. How to make an adapter that can connect a high-efficiency particulate air, or HEPA cartridge, to an anesthesia mask.
Hey Tim, how are you?
I'm very good. How about you?
I'm doing fine, thanks.
Awesome.
Tim is Tim Doherty. He's the Director of Workforce Safety for Lehigh Valley Health Network, or LVHN. LVHN gave the Lehigh team feedback on early prototypes of the face shield. Tim had read about medical professionals creating respirator masks by fitting filters to anesthesia masks. His hospital had an abundance of both. If he could marry the two, he'd have a backup solution if they ran out of N95s. He'd asked Brian for help. Brian figured out a design on his drive home from Lehigh, sent it to the 3D printer the next day, and had a solution in less than 24 hours. Now he was handing off a bunch of his 3D printed adapters for Tim to test.
Greatly appreciate.
Do you have a sense of how many of these you might need?
You know, right now we have pretty good reserves on the N95s. What we're looking for is we have a few docs that are very petite and they don't fit any of the N95s. So we're looking at this for those individuals right now so that they can get fit tested. And depending on how long this goes on, as we burn through our N95s, this might be a viable alternative.
Yeah, okay.
If the connector passes testing, Tim tells Brian to upload the design with the National Institutes of Health, which has an open source page for helping address the supply shortage of PPE.
I think it would be wildly popular.
Okay.
I mean, because so many hospitals are just desperate for solutions, and this is an awesome solution you've helped us come up with here. So,
all right.
So thanks so much.
Yep, no
Have
problem.
A great weekend.
Yep, you too. Bye.
So this has been really a chaotic kind of roller coaster ride because it's been exceedingly unpredictable, what our needs are going to be as well as what our availability is.
I called Tim to better understand the supply challenges. He says prior to COVID-19, hospitals didn't really use reusable face shields, and that before the pandemic, many products worn in a medical environment had to go through government approvals. But he says, we're in uncharted territory with a broken global supply chain, where hospitals now operate in a contingency or crisis capacity. He says agencies like the FDA and CDC issued general guidance, telling them if you have approved PPE, use it.
However, if you no longer have those items available, you're going to have to get creative.
And he has been able to get creative, thanks in large part to the innovative solutions coming out of Lehigh.
Especially in the earlier days when the CDC seemed to be changing the guidance every couple of days on what PPE to wear. So when I would go up to staff members that might have had on safety glasses as well as an N95 or safety glasses and a procedure mask, and when I would give them one of the Lehigh face shields, you could almost see tears well up in some of their eyes. Like, thank you, thank you, thank you. They were so grateful to have something that is so much more protective.
Sandy Marone is also grateful. She's the manager of inpatient physical therapy services at Good Shepherd Rehabilitation Hospital in Allentown. She treats COVID patients and wears a Lehigh face shield every day. Lehigh helped boost Good Shepherd's stockpile of face shields from a 12-day supply to a 5-week supply. Sandy says the shields are lighter weight, more adjustable, and better padded than the commercial shields that she's worn. And comfort matters when you're wearing something for 8 to 12 hours. But what she's really grateful for is how much an organization like Lehigh cares about the health of the community.
So my staff are like my family, and our patients are our first priority as well. So we want to make sure we're protecting them from any potential spread or exposure. So having the best things in place to be able to do that means everything during this time.
Back down the mountain in Wilbur Powerhouse, Trevor is about to begin the next 24-hour print cycle of the headbands.
All the printers are now ready to go, so I'm going to go ahead and get them started.
Trevor describes the 3D printing process as essentially a hot glue gun hooked up to a controller. The nozzle deposits a single layer of melted plastic. With every layer, the build tray drops by 300 microns, about 1/100th of an inch. Then another layer is added on top. The final stack of headbands will be about 12 inches tall. One thing that has struck Trevor about this experience is how fast they were able to get prototypes out to hospitals and finalize a design.
Typically, you would expect this process to be weeks and weeks of iterations where we'd work on a design, print it, send it out, back and forth. And that really wasn't how this happened. It was really quite fast.
Lehigh has a lot of advantages that contributed to that speed. The university has the technological capacity. Brian and his team can leverage a variety of technologies to get the best out of each one. And that capacity, it's also an intellectual one.
We're good at designing solutions to things. That's what I do. I teach students how to make and design stuff. So, all of this is in our wheelhouse from that respect.
Lehigh's quick response also speaks to the connections that the university has built with the community.
We've spent a long time and a lot of institutional resources building relationships, and those relationships are with the local hospitals. I think pretty much everybody I've dealt with, both at St. Luke's and Lehigh Valley, at some point has been in the additive lab, and I've given them a tour of our capabilities and talked to them about how additive manufacturing can be brought to bear on some of their healthcare needs.
Trevor, Michael, and Brian never anticipated becoming essential workers during a pandemic. But when the call came, there was never a question how they or Lehigh would respond.
I have to say, people have been so appreciative in this process, and it just, it feels so good to be able to do something. So when you drop these things off and you see people, just exude thankfulness and gratitude that you're doing this, it makes it very real in a way that it, up until that point, it was a design project, really.
Brian has been talking to his students about all of this, and he tells them this is what engineers do. They respond to a need, and they use their powers for good.
And I think in this moment, to be able to do something where you're potentially helping somebody stay safe, that to me is the core of what we should be doing as humans, as engineers, as Lehigh practitioners. That's the place where we can make the greatest difference in the world. And so it's so exciting to be able to be part of that. It's humbling to be part of that. And it's nice to feel like we can offer something during this time of just total chaos.
That's it for this week's show. When this episode was recorded, Brian, Trevor, and Michael had delivered between 1,200 and 1,500 face shields to local hospitals and emergency management agencies. They haven't been great at keeping track because they've been pretty busy. Lehigh University has so far funded this entire effort and made it possible, but Brian's team will need additional support to keep operating. DuPont recently donated a 1,000-foot roll of PET plastic, enough to make 1,000 face shields. If you want to contribute to Lehigh's work protecting our first responders and healthcare providers, there's now a crowdfunding site. You can find the link at engineering.lehigh.edu on our podcast page. Rawson Connection is hosted and produced by me, Christine Fennessy. But there is no way this episode would have happened without the recordings made by Brian, Trevor, and Michael. They are the ones who brought you into their labs and out on the road. They helped us all understand the process behind their critical work, and I am so thankful for their time and patience in taking a crash course in audio reporting in the era of social distancing. And thanks to Brantley Hightower for help with the script. Please subscribe to our show. You can find us wherever you prefer to listen. Reach out to us on Twitter at Rawson Podcast with story ideas or feedback. And to find more information about academic programs at the PC Rawson College of Engineering and Applied Science, head to engineering.lehigh.edu. Thanks for listening, and stay safe.